Okay guys, today we are going to see a problem based on SOFM. So SOFM stands for, or SOM is self-organizing map, or the full form of SOFM is self-organized origination feature map. So SOFM stands for self origination feature map. Okay, so today we're going to solve a problem based on this. So it's like a neural network and we have to update the weights. So already we have learned that. So we're going to see how we are going to do a numerical problem. So the diagram will be given like this. So in this we'll call it as x1, x2, x3 and x4. We have c1 and c2. 1, okay, we have vectors like this and we have these nodes. Okay, so in these nodes we'll have some data, some values here, 0.2, 0.9, then we have 0.4, 0.7, 0.6, 0.5, 0.8 and 0.3. okay, and we call it as W11, W21, W31, W41, and here again W12, W22, W32 and W42. okay, then we have something called as input vectors. So how many input vectors are there? We have 4. I is equal to 4, and then for I1 we have these values here, input 0, 0, 1, 1. This is I1, I2 1, 0, 0, 0. You can please refer the PPT that I uploaded. You can see it's just explanation of the problem that is solved in the PPT. okay, then 0, 0, 0, 1. Now in this problem we'll be getting something called as learning rate, or alpha, or we can call it as learning rate. So learning rate is given here, that is 0.5. okay, now we have to calculate step by step. So step 1, now we know there are two inputs, one is C1 and C2. If you see, sorry, two outputs, that is C1 and C2. We can also write it as W weights 1 and WI2, that is input weights of C1 and input weights of C2. So you have 4 input weights, right, that are connected to each node. So you have to write the values here. So if you see from the diagram, for this input weights, that 1, 1, 2, 1, 3, 1, 4, 1, 0.2, 0.4, 0.6, then again 0.8. So write it down here, 0.2, 0.4, 0.6 and 0.8. Then WI2 will get 0.9, 0.7, 0.5, 0.3. okay, we got the table here. Now our task is to calculate Euclidean distance, okay, with each instance. So we have different instance here, right? Instance 1, instance 2, instance 3 and instance 4. These are the inputs. See, these are 4 inputs and the outputs will be getting. So this is first input, this is second input, this is third input, and this is fourth input. That is instance or inputs that we say here. okay, then next, for each input you need to calculate the Euclidean distance and need to update weights. Okay, I'll show you for one instance, then you need to keep on rotating for 2, 3 and 4th. I'll show you for the first two, then you can do easily for the third and fourth, and for finally in the fourth, whatever answer you will get, that is the final weight updation. Okay, so first instance will do. So first instance is I1 is, what is the value here? 0, 0, 1 and 1, right? Now everybody knows our Euclidean distance, so for each you have to calculate the Euclidean. So distance of C1, so we'll calculate for this. So what is, how we'll calculate, we know, right? So we'll calculate this. So first is 0 minus this 0 point minus 0 0.2 whole square plus 0 minus 0 0.4 and square plus 0 minus 0, sorry, it will be 1 minus 0 0.6 whole square plus 1 minus 0 0.3 whole square. Now we know in Euclidean distance there is square root, right? Top we have square root, but this is, you have to calculate squared Euclidean distance. Okay, so that's why whatever value you'll be getting, we'll be putting that directly. So if you calculate this value, we'll get 0 0.4. Then again we need to calculate for C2, right? So again for C2 we need to calculate. So 0 minus 0 0.9, so I'm writing it down here. 0 minus 0 0.9 whole square plus 0 minus 0 0.7 whole square plus 1 minus 0 0.5 whole square plus 1 minus 0 0.3 whole square. So the answer that we'll be getting is 2.04. Now you have two distance here. Now you have to calculate which is the smaller distance. So this is the smaller distance, right? If you see, so DC1 is smaller than DC2, so we will be taking C1 value. Okay, the smaller value. Now we need to update weight for this thing alone. Okay, we need to update only for the C1. So what is the formula of C1 is W weight Ij of nu is equal to Wij old plus alpha xi, that is the distance Wij old. Okay, so how do you calculate? We need to update for only this, that is C1 here, because we found it as smaller, right? So we need to update weight. So we need to calculate for each one. W11, W21, W31 and W41. Yes. Now how to calculate? So what is saying Wij old? What is the old weight of W11 is 0.2 plus 0.5. Now what is this? This is the distance or the input. If you see here, this instance, okay, 0, 0, 1, 1. So I need to put it here. So 0 minus Wij, that is old, so 0.2. So you'll be getting 0.1. Similarly here 0.4 plus 0.5, that is the learning rate. 0 minus 0.4, so we'll get 0.2. Similarly if you calculate here 0.8 and 0.9, so we update it. Now you have to write here a new table, that is with the updated values. Only we updated for the Wi1. Wi2 we still didn't update it. Okay, it will be depending based on our instances. Okay, so after updating we got the new values 0.1, 0.2, 0.8 and 0.9. Then again 0.9, 0.7, 0.5 and 0.3. Then again we need to calculate the next step with the second instance, step 2, that is with second instance. Okay, If you calculate the second instance, again you will get dc1 and dc2. So if you calculate dc1 and dc2, we'll get 2.31 and 0.84. Now previously we checked which is the smaller value, so now dc2 is smaller, right? This is smaller, right? So we'll be updating which one? We'll updating weight for dc2. Then again we'll put the same formulas. Now you need to update weights for w12, w22, w32, w3 sorry 4 2. So we'll update the weights, right, like the previous steps. So we'll get the new values as 0.95, 0.35, 0.25 and 0.15. Yes, now we'll keep on repeat for all the instances. So finally, after putting all the instances, the final updated value or updated table will be looking like this. So final updated weight table will be looking like this. So wi1, wi2, so the updated is 0.025, 0.95, 0.3, 0.35, 0.45, 0.25, 0.475 and 0.15. Okay, now after all these things, we can close it with this updated indexes, or finally we can calculate, or like our statement we can write it at below like this, like the final updated table is written above. Okay, so that should be your final answer. Thank you.